beautiful blue ring of light, and there's some lights inside that you can actually see through the top. You look, the first thing that you notice is that coming out of the box, you don't have to assemble a whole bunch of tubes and wires to it. Connected to the back, no pre-assembly required, is the 3-in-1 cable, right? That contains the inlet from your water, and then the outlet. This is the clean coming out, and also a power cable is in there as well for the diverter. And then of course there's the power for the wall socket. This is the diverter that I was talking about. It's touch sensitive. So nearly every one of the diverters that we saw, you might attach it to your faucet, but then you have to like struggle with some kind of a handle or a lever. This has a little servo inside. And so you just press it. You don't even sort of indent it. You just touch your finger on it and then it switches over to filtration mode. So it's a beautiful, sleek design. And we'd never seen one of those before, this unit. The other thing, probably the most difficult thing about assembling a water filter when you get it, is how to attach it to your faucet. Right? Lots of different things, and a lot of the time when we opened the box it didn't have everything that we need. This one is really simple. You get a choice of 6, and you have to choose number 5, and then you screw it into number 3. And then number 3 you add to number 1 or 2, depending on what kind of system you have. I'm just kidding. You choose the one that works for your faucet, right? It's one of those will work. And then you screw that onto the faucet. And then once you've done that, you're pretty much ready to go. The diverter then snaps right onto that adapter. All you have to do now is put the filter inside the unit. It's a 3-in-1 filter. Not 3 filters, but 3 filters in one, right? And then you just give it a quarter turn, and you're in. No plumbing, no tools, no exposed filters, no disassembly. It's so simple, actually, that we had a competition in Malaysia a couple of nights ago, and we got 6 people lined up, and they'd never seen the water filter before, and they had to put the diverter on, put the adapter on, put the diverter in, put the filter in, plug it in, right? That's what they had to do to assemble it. How long do you think it took the winner? 54 seconds. So we said, this is too easy, so we got 6 more people up, and we blindfolded them. It was really fun. One of them kept trying to touch the other person next to him, so he was disqualified. But the person who won, 2 minutes and 10 seconds. Right, so you can do it blindfolded, it's so easy. That's the design of it. So it's ultra pure technology. Let's talk then a little bit more detail. I've got a few more minutes about what's actually inside. Okay? It starts with the pleated pre-filter on the outside. You can see, like many filters, it's accordion shaped to enhance the surface area of that filter. Now, I told you we did a whole bunch of homework on this. Not all pre-filters are the same, okay? This is not paper. It's not something cheap that will wear out fast. It's a very tightly woven polypropylene, and it protects the rest of the filter, so any turbidity that's in the water will stop right there. The next part of the filter, which is really a big part of the workhorse, is the compressed carbon block. Now, I learned a lot about carbon in the last 3 years. Okay, carbon is really interesting stuff. It's mostly, for water filtration, made from the husks of coconuts. I hear there are some growing in these parts, right? A lot of waste goes, right? So you turn that into carbon, and then even then it's not ready. Actually, you have to treat it with high pressure steam, and it creates these little channels in the carbon, and this is called activation, which gives it a huge surface area. I'm sounding like Donald Trump now. Huge! Right? Huge surface area. How much? Well, there's about 3 grams of this activated charcoal that you can put into a teaspoon. Do you know what the surface area is? About the size of 1 football field. So each kilogram of activated carbon is about 1 million square meters. So it has amazing ability now to absorb and to trap. So you can do it by granulating it, and a lot of the filters that you buy can do that. You have a granulated activated carbon that you would pour into the filter. Just imagine a big tube of this. You pour water in the top, and the water goes through the activated carbon, and clean water comes out the bottom. Right? And that works quite well, actually. The only problem is that over time, water finds the easiest way. It's called channeling. So what happens is some of the water sort of finds a river through there. It doesn't actually go through the carbon very much, so not all of the water is filtered. So we don't trust that 100%, even though it's quite good. So now you have to have a carbon block. And a carbon block is built one of two ways. You can get all of that activated carbon and you can put a binder, some glue and stuff in there, and you stir it up and you squeeze it through a machine under pressure and it comes out like a sausage, and you let that dry and you carve it up and you use it. But it's not quite as reliable. It's a lot cheaper, but it's not as reliable as a compressed carbon block. Okay, the compressed carbon block, you actually put it in a mold and you use a huge amount of pressure to make a carbon block. That's the most reliable, that's the most expensive, but it's the best and most reliable. So we thought to ourselves, which one should we use? Should we use the cheaper one that's less reliable, or should we use the more expensive one that is reliable? Decisions. What do you think we did? Of course, we got the best one, because this whole thing is about getting the best technology. Okay, the third stage is really unique as well. Something that we actually stole from, didn't steal the technology, but this is something that we've never seen in a benchtop type water filtration system before. This polyether sulfane membrane. Okay, this is the third stage. It is used in a lot of reverse osmosis systems, but we use this technology here. So we have these, to increase the surface area, there are these tubes that have little holes in them that are about 10 nanometers. So this is kind of nano-type technology filtration. This is going to get the smallest of the small particles and bacteria and viruses out of your water. Surface area you see is just really extremely fine. And we need to do it that way so that we don't slow down the flow, even though we're doing ultrafiltration. Okay, so this is very unique in this kind of a filter. And the final stage then is ultraviolet light. If anything gets through, ultraviolet light then knocks it dead. Because ultraviolet light then is tuned to destroy DNA in bacteria and viruses. Okay, do you trust this filter yet? Yeah. I hope so. Okay, so I want to talk about logs again for a minute, because I love logs. Right? You understand the logarithmic scale now. The thing about this is the acid test of a really good water purification system is how many logs reduction in microorganisms you can get. Right? How many tenfold reductions you can get. Got like a minute left, don't I? All right, we're nearly there. Okay, so here's an example. You've got 1 million bacteria in your little glass of water. You need to filter that. The question is, how satisfied are you? How low do you have to go before you're satisfied and you want to drink that water? Now, if you get a 90% reduction, right, in that, so a sort of a tenfold reduction in that million, that takes us to 100,000 microbes, right? 90% of 1 million is 900,000. Trick question. What's the 10%? 100,000, right? So if we do a 90% reduction in bacteria, are you happy you're going to drink that water? Yeah, it's still got 100,000 bacteria in there, and some of them might be typhoid or cholera or something. I'm not going to take the risk. All right, so if we do a 2 log reduction, then we're going to have 10,000 left, right? So, 1/10 of the 100,000. 2 log reduction, we're still not down to 0, are we? You have to do 6 logs, or 6, tenfold reductions before you basically get down to 0. And so that 6 log reduction is the standard that we're going for in terms of water filtration. Are you happy with that? Yeah, we need to get to 0. That's the standard, and that's what we're able to achieve with this water filtration, which means 99.9999% reduction. That's 6 logs. So now you know all about logs when it comes to pH, to earthquakes, and to reductions in microbes. Awesome. Give yourself a round of applause. Right, we passed the chemistry class. So, we want to remove all of these things, but one thing that we notice is that in our water filtration system, we don't get rid of this, dissolved salts, all right? So dissolved salts are things like magnesium and calcium and stuff that ends up in the water, and it actually makes it taste good. There are a lot of companies that bottle water that add those things back in. Okay, so that's going to be good for the taste of the water, and this filtration system does not remove those, which is a good thing. Now I want to show you 2 videos real quick. I'm out of time, but we've got time for a couple of videos. First video is going to show you how our ultra pure system gets rid of turbidity. So we've got some really nasty brown water. We're going to show you how good this system stands up to that. Okay, so I'll show you that one first. Looks more like Coke than water, doesn't it? Anyone up for a drink of water? It's cold. What if you boiled that? Would you still drink it? Okay, now we're on the filtered version. Hard to believe that was the same water once, isn't it? Alright, so that's a dramatic demonstration. And that's a demonstration of things that you can see. But water still contains a lot of things that you can't see that are harmful, right? Things like lead, or things like even chlorine. Now, I said chlorine. Chlorine is not harmful. In fact, it's wonderful for removing bacteria from the water. But once you start to drink it, it kind of ruins the taste, right? And did you know that you have a whole bunch of friendly microorganisms in your GI tract? Friendly bacteria. And drinking lots of chlorinated water actually can disturb that healthy population of bacteria, which isn't good for your overall health. So it is nice to remove the chlorine from the water before you drink it. It tastes better, and it's better for your body. So let's look at one more video, if we could. And this is a video that shows the removal of the chlorine using our filter. Okay, so we're just going to look at tap water right now. We haven't pressed button for the filtration on the diverter, and we can use an indicator that is sensitive to chlorine. So DPD will turn pink if there's any chlorine in the water. We did some water in Malaysia a couple of days ago, and it was actually even brighter pink than that, wasn't it? So there's a lot of chlorine in tap water. Now let's filter it. And then we'll use the same indicator, and if it turns pink, we'll know there's still chlorine in there. Beautiful. No chlorine present to react with it. Alright, so that's about it for me. I hope that you've learned a bit about water filtration, how important it is, things that you can clean from it. I hope that you can experiment one day with not having to boil the water that comes out of the filter from your tap. Thanks very much, everyone. Drink healthy.